Dear students, here I'm going to discuss one infinite sequence. Basically here I'm going to discuss some basic definition of one infinite sequence and simply sequence, and I will explain here some related examples also. So what is sequence or infinite sequence here? So in mathematically, a sequence we may consider as a ordered list, or we may also consider it is like a set, and it contains some members and which are called the terms of the sequence. We may also define an infinite sequence in other way. Each sequence can be defined as a function whose domain is the set of natural number. That means a sequence whose domain is a set of natural number may consider an infinite sequence. That means a list of elements or objects which are associated with the set of natural number is called an infinite sequence. And if a sequence contain infinite number of terms, then the sequence is called simply infinite sequence. Or if a sequence contain finite number of terms, then the sequence simply is called a finite sequence. And the number of ordered element is called the length of the sequence. That means what you can see here, in case of infinite sequence, the number of the length is infinite, and for a finite sequence the length is finite. Now what is the difference between actually set and sequence here? So I think we all know about the set theory. So in case of set, we don't allow the repetition. That means in case of set we can't use the same element here, but in case of sequence or infinite sequence, there may be same element can be appear in multiple times. That means in case of sequence the repetition is allowed, and also in case of set the order does not matter. That means the position of the elements are not matter, but in case of sequence the order or the position of the members are matter here. Now in mathematically we write a sequence of the form this one: S1, S2, S3, S4, like this one, where this S1 is called the first term, S2 is called the second term, S3 is called the third term, and so on, and we denote by this. Here we consider some infinite sequence, so a sequence of this form. So here if we put n equal to 1 we get minus 2 by 3, if we put n equal to 2 we get 3 by 9, and so on. So clearly this is a sequence, or this is an infinite sequence in which this is the first term, this is the second term, and this is the third term, and so on. And here the nth term is this one, this is called the nth terms. We consider here another sequence, this one. Here if we put n equal to 1 we get this value 1 by 2, if we put here n equal to 2 we get this one, and so on. And this is an infinite sequence in which this is the first term, this is the second term, this is the third term, and so on. And here the nth term is this one. We consider another sequence here like this one. So now we will discuss here limit of a sequence or a sequence. suppose Sn here, when this sequence Sn called has a limit point, suppose L. So here we consider the sequence this Sn and consider L is a fixed number, any real number. Now if for every epsilon or every positive quantity, small quantity which is greater than 0, if there exists a corresponding integer capital N such that this is all, that means the difference, modulus of this difference is less than always epsilon. For all small n greater equal to capital N, then this L is called the limit point or simply limit of this sequence Sn. And we write like this: limit n tends to infinity Sn equal to L. Now convergency or divergency of a sequence, or when a sequence is called convergent sequence, or simply when a sequence is called divergent sequence. So here suppose we consider a sequence, suppose this Sn, and if this limiting value, limit n tends to infinity Sn, is finite, then we call this sequence is convergent simply, or otherwise the sequence is divergent sequence. Okay, so here we consider some examples of convergent sequence. So here consider a sequence, suppose Sn, and where this Sn equal to this one, and if we take here this limit value, then this limiting value will be in E, and since E is a finite number, that means this implies the sequence this Sn is a convergent sequence. So here we consider another example. He consider a sequence this Sn where Sn equal to this one, and if we take this limiting value, then this is value will be infinity. That means this is an infinite value, or this is not a finite value. That means the sequence is not convergent. That means this sequence is divergent sequence. So here I will discuss some properties on limits. So we consider here this Sn and Sn, these two sequences are both convergent, and suppose k is a constant number, then these following properties are held. This one, that means limit n tends to infinity Sn plus minus Sn dash equal to this one. Suppose k is a constant, then limit n tends to infinity k of Sn equal to k of limit n tends to infinity Sn, this one. And here we consider a constant sequence, that means a sequence in which the all terms are equal to k, and if we take this limit, then this value will be k. This is another properties on limit. This is another properties on limit. So thank you.